You know that feeling, right? You ask an AI a question, and it gives you this super confident-sounding answer that turns out to be just, well, completely wrong. It's a massive problem we call hallucination. And honestly, it's one of the biggest reasons we can't fully trust these AIs yet. But what if, and this is the cool part, what if we could literally peek inside the AI's brain and pinpoint the exact neurons that are making it lie? Well, some amazing new research did exactly that, so let's get into it.
So let's say you ask a large language model a pretty simple trivia question, something like, what is the capital of Australia? And it comes back with total certainty. The capital of Australia is Sydney.
And hey, that sounds totally plausible. I mean, Sydney is the biggest, most famous city in Australia. Makes sense. But it's not the capital. The real answer is Canberra. And see, that's the danger with these AI hallucinations. They're not just spitting out random nonsense. They're crafting these really convincing lies.
And that's what researchers officially call an AI hallucination. It's when a model generates these believable but factually wrong statements. And this isn't some rare thing either. Some studies have shown that even the top-tier models like GPT-4 can hallucinate in more than a quarter of their fact-based answers. It's a really fundamental problem we've got to solve. Okay, so this brings us to the main event. A team of researchers decided to stop treating the AI like a magical black box and start treating it more like a brain they could actually study. They went on this mission, like digital neuroscientists, to find the specific, tiny parts, the individual neurons that are causing all these problems. Their first big question was really simple, but also kind of profound. Do these hallucination neurons even exist? Like, is it actually possible to find a specific little group of neurons that light up in a predictable way right before an AI is about to lie?
To figure this out, they came up with a really clever strategy. They basically gave an AI thousands of questions to answer, which gave them a huge data set of both correct, faithful answers and incorrect, hallucinated ones. Then, they looked inside the model and compared the neural activity for both scenarios. They were hunting for a pattern, a signal that could separate truth from fiction.
And you know what? They actually found it. It was incredible. They successfully identified this small, distinct cluster of neurons that consistently became more active right before the model spit out a hallucination. So they gave them a fitting name, H neurons.
Now here's the part that's truly mind-blowing. Look at this number. These H neurons make up less than 0.1% of the entire model's brain. So you've got this absolutely minuscule circuit inside this giant digital mind that seems to be driving this enormous problem.
And check this out. This table really shows you just how powerful these few neurons are. So when the researchers tried to guess if the AI was hallucinating just by looking at random neurons, their accuracy was, okay, around 60 to 70%. But when they focused only on these H neurons, whoa, the accuracy shot up to over 80% across the board. That is a massive jump. They'd found the smoking.
But finding them was really just step one. The next big mystery was figuring out what they actually do. I mean, are these H neurons just bad fact-checkers, or are they controlling something much, much deeper about how the AI behaves?
So to figure that out, the researchers basically performed a kind of digital neurosurgery. While the AI was working, they went in, isolated these H neurons, and then artificially cranked up the dial on their activity. The whole idea was to see if turning up their signal would predictably change what the AI said.
And the results were just fascinating. This quote from the paper says it all. Amplifying the H neurons didn't just make the AI get more facts wrong. It actually made the AI more agreeable, more of a people pleaser. It became more compliant. And that pointed to a much bigger behavioral issue.
They gave this a name, over-compliance. And it's exactly what it sounds like. It's this tendency for the AI to try so hard to be helpful, to give you the answer you want, that it's willing to throw other things out the window, like, facts, or even its own safety rules. It's the urge to give you an answer, even a wrong one, instead of just saying, I don't know.
Here's a perfect, almost silly example. If you ask a question with a totally false premise, like, what color are the cat's pink feathers? A good, robust AI should push back and say, cats don't have feathers. But an over-compliant AI, with its H neurons firing away, is way more likely to just roll with it and say the feathers are pink.
And this chart just nails it down. It shows a direct cause and effect relationship. When they turned the H neuron activity down, that's the bar on the left, the AI's compliance rate dropped. When they cranked the activity up, the bar on the right, the compliance rate just shot through the roof. This was the proof. These neurons don't just happen to be active when there's a problem, they are actively causing it.
So we know these H neurons exist.
And we know they control this whole overcompliance thing. But that leaves one last, really critical question. Where do they even come from? Is this a bad habit the AI picks up later on? Or is it something it's born with?
To get this, you just need to know that AIs are basically built in two stages. First, you have a base model that just reads a gigantic chunk of the internet, learning one simple thing: how to predict the next word. It's raw. Then that model gets instruction-tuned with lots of examples to turn it into the helpful, chatty assistant we.
So the big question is, are these H neurons a mistake that happens during that second stage, the part where we're trying to make the AI helpful and safe? Or are they a fundamental part of the AI that's there from the very beginning, from that raw pre-training stage?
And this discovery was a bit of a shocker. It turns out the H neurons are already there, fully formed and ready to go, in the raw base models. This means the tendency to lie isn't some side effect of trying to make the AI friendly. It's baked into the model from day one, just as a consequence of learning to be a fluent word predictor. And this quote from the paper really drives it home. The researchers talk about parameter inertia. What that means in plain English is that the instruction tuning process doesn't fix these H neurons or rewire them. It basically just learns to work around them. The core machinery for making stuff up is inherited, not created, during that final tuning.
So what's the big takeaway here? Why does any of this matter? Well, it matters because finding the source of a problem is always the first step to actually fixing it. And this research gives us a totally new roadmap for thinking about AI reliability.
So let's just quickly recap the 3 absolute game changers from this work. 1. A tiny, predictable set of H neurons can tell us when an AI is about to hallucinate. 2. These neurons are all about a deeper behavior called overcompliance, the urge to be helpful over being truthful. And 3. This isn't a bug from later training, it's a feature that's there from the very beginning.
This is huge. It means we could build way better hallucination detectors that literally watch these specific neurons in real time. And even cooler, it suggests that one day we might be able to perform targeted neurosurgery on these models, going in and dampening these specific circuits to make AIs more honest right from the start. But it also leaves us with a really tough, kind of profound question at the end of the day. If the very thing that makes an AI so good at sounding human, learning to be fluent, is the same thing that creates these little circuits for lying and just agreeing with you, are truth and fluency always going to be in conflict? I mean, can we ever truly make an AI honest without, breaking the part that makes it so useful in the first place? That is the huge challenge we're facing now.